Hello students, so today we will be starting a new chapter, chapter number 11 called Force and Pressure. This is very basic chapter because force and pressure would come in all the classes when you are studying physics. It's most basic term, so try to understand it carefully so that the concepts are fully understood. The content of the chapter is displayed in this slide. First I will explain to you what is force, then how does the force arise, then we will study about the forces in bit detail, then we will study what are the effects of the forces, because force cannot be seen but its effects can be seen. Then various types of forces. So that completes part 1 of the chapter. Then part 2 is regarding pressure. We will study what is pressure, what is the pressure exerted by liquids and gases, and about atmospheric pressure. So these are the contents of this chapter that we are going to study. So let us study one item by item. So first I told you we will study what is force. See, to understand what is force, let us try to see that what observations we make in our day-to-day life. Like you might be seeing a ball, if you are rolling it on the floor, then gradually its speed decreases. When a batsman hits a ball, the ball goes up and then it falls down. A hockey player, using his hockey stick, he changes the direction of the ball. So, you are lifting some article, some suitcase. So in all these observations, what actions we are doing? In English language we use various words, like we say he is picking an object which is on the floor, or open the door, shut the door, kick the ball. Hockey players will hit the bat, or we will say that he is lifting, he is pushing. In doors you might have seen, in one side it is written push, in the other side it is written pull. So push, pull. These are the various terms that we see that when we perform the actions we do it. As such, if we see these terms, we are doing only two things: pushing or pulling. I will explain those with the same examples. Like push means you are making an object far away distance from you. At whatever distance the object was with you are increasing that distance. And pull means you are decreasing the distance between you and the object. Now let us try to see. When I say in the door is written push, you are pushing it, so you are increasing the distance of the door from you, and in the space that is generated you walk in. If we pull something, then we are decreasing its distance from us. Okay. Now let us try to see. When we are picking, suppose you are lifting a bucket of water from the well using a rope, so you are lifting it. So when you are lifting it, you are decreasing the distance. So if we decrease the distance, we will say you are pulling the bucket up. When you are kicking a ball, you are increasing the distance. So means we can use the word you are pulling action is taking place. So in this manner, instead of using various terms, we will see that we are either pushing or pulling an object. Now, so what is force? So force is either a push or a pull. In simplest terms, we can say a force is either a push or a pull. If a car is stationary, it is not starting. You will, some few persons may push the car from below and the car will move. Or if a truck has, if the truck has got some problem, then you connect it to trailer and you pull the truck from its place. So these are called forces. So force means it is either a push or a pull. So this is very important. You should learn force is either a push or a pull. Now we know what is force. Now what changes does this force bring about? As I say, somebody is lifting from the ground some object, so he in the ground it was stationary. Now when it's lifting, you are moving it, so means you are increasing its speed in the vertical direction. When a cricketer hits a ball with a bat, he is increasing its speed in the forward direction, or is changing the direction also. When a hockey player is hitting a ball, he is changing the direction and increasing the speed. Now, as I told you, when a ball is rolling on the ground, its speed decreases. So means again some force is acting on it, which we are calling it frictional force. And frictional force always acts in the direction opposite to the motion of the object. Opposite, you can say, to the relative motion between the two surfaces. So when the ball is rolling on the ground is stationary, so the ball is moving in forward direction, so frictional force will act in the backward direction. If the ball is moving towards the north direction, frictional force will act towards the south direction. Always frictional force direction is opposite to direction of motion or direction or between the relative motion between the two objects. If the relative motion is towards the north, the frictional force will act towards south. Now, a fielder catches the ball and brings it to rest. So ball was moving with a good speed, the cricketer brings the ball to rest. So means he has applied certain force. So force is causing a stationary body to move, a moving body to stationary, or we can increase the speed or decrease the speed. So force is that physical quantity which changes the state of motion. Instead of telling various things, we say it changes the state of motion. So what do we mean state of motion? Means body is stationary or body is moving in certain direction. So if we increase or decrease the speed or change the direction, we say force is acting. So whenever you find the change of motion or change in state of motion, it means some force is acting on the body. So force is that physical quantity which is causing change in state of motion. Is it all right? So this is one important thing that force does. Force does another thing also. It changes the shape and size of body in case body is not a rigid body. Like you take a cotton, you take a pillow, you apply the force, you are changing its shape and size. You take clay, you press the clay with your hand or fingers, you are changing its shape and size, it can change. So So the complete definition would be force is that physical quantity which changes the state of motion, earth's shape and size of the body. Is it okay? Now what is force? Now, if a car is not moving, engine is not starting, so car is stationary. If four persons are at some distance from the car, will the car move? No. Those four persons will have to come and push the car with their hand, or they have to push the car with the hand, then only the car will move. So this is called interaction of bodies, interaction of forces. Like when an accident takes place, two vehicles were moving, and now when they collide with one another, each body applies the force to another body, so its motion changes. So this we say there is an interaction between bodies, or interaction of forces are taking place, and then only the body will move. The four persons are pushing the car, means they are applying the force to the car, and the car moves. So this is called interaction of forces. Now, if there is a box, okay, this is a box, somebody is, person A is applying force to A in this direction, so this will move in this direction. But now another person B also comes and applies the force in opposite direction. So then this will move in the direction AB if the force of A is more than B. In case the force of B is more than A, then the body will move in the direction BA. And in case both the forces are same, the body will remain stationary. It will not move. So what does this indicate? This indicates that force has got a direction. We will be learning in higher classes that unit of force is Newton. So if A is applying a force of 10 Newton and B is applying a force of 8 Newton, then this body will move in AB direction as if only 2 Newton of force is applied. And in case B is also applying a force of 10 Newton, in case B is also applying a force of 10 Newton, body will not move at all, because 10 Newton towards right and 10 Newton towards left will cancel one another, like plus 10 and minus 10 cancel and will get 0. So this body will not move. So we say force has direction. We will be learning in later classes that physical quantities which have magnitude as well as direction, they are called vectors. So we will say force is a vector. So this word you should learn, that vector. Vector means physical quantities which have magnitude as well as direction. Like you have 40 rupees. So this money doesn't have a direction. So it is a scalar. Quantities which do not have director, they are called scalars. In physics, if I say length of this pen is 12 centimeter, so length does not have a direction, so it is a scalar. Quantities which do not have a direction are scalar, but quantities which have magnitude as well as direction, they are vectors. Okay, so force belongs to vector. Force is a vector quantity, whereas length, area, they are scalars quantity. Mass of a body is 40 gram. So it is a scalar. Mass does not have a vector. Mass is quantity of matter. Is it all right? So that is why we say, like suppose there is a tug of war. Tug of war, you know that there are two groups of people. This is one group of people and this is another group of people, and both are pulling this rope. Suppose this is a rope So they are all pulling in this direction, they are pulling in this direction. This is a rope. So there are certain people pulling in this direction and certain people are pulling in this direction, and this is the middle. So in case this does not move, means both are pulling with the same direction, and in case this moves towards the left, so means persons from the left side are pulling it with a larger force. Force towards the left is more. Is it all right? So this is about force. So now we have understood what is force. Force is that physical quantity which causes change in state of motion or change in shape and size of body. Example, clay, pillow, all these bodies which are not rigid, their shape and size can be changed. Is it all right? So we'll proceed further. So we have understood now what is force. So in conclusion, what does force does? It may make an object to move from rest. Like car is stationary, when persons apply force to it, the car may start moving. It may change the speed. It can increase or decrease the speed of the body. Like fielder decreases the speed of the body in case he applies with the force with his hand and the ball comes in his hand. So means speed has become 0, or the speed may decrease. Like due to friction, when you are rolling a marble on the ground, its speed decreases gradually. Okay, like now suppose if a person is a body is moving, like you might have seen a small game, like suppose this is a tire. The tires are rolling, and with some stick you are rolling, pushing this tire, so the speed will go on increasing. If a body is moving in some direction, you apply the force in the same direction, its speed will increase. Like a car is suppose moving at a slow speed. Now one more person comes, he also pushes, the car will move at a higher speed, because the force has been applied in the same direction. But in case you apply the force in the opposite direction, the speed will decrease, because the value of the net force would become less. As we have learned, force is a vector. Okay, so force can move an object from rest, it can change the speed, it can change the direction, or it can change the shape and size of the body. Okay, or it can do even two things, more things. Now force, we can say, are of two types: contact force, non-contact force. As I explained to you, a person has to touch the car and apply the force, it will move. So it is called a muscular force, because from the energy required for this activity is given by the muscles. And when the speed of a ball decreases on the ground, is friction, so that is also contact. In case the body does not touch the ground, there will be no friction. So these are contact forces. Then we will be learning non-contact forces are of three types: gravitational, magnetic, or electrostatic. I will explain you this, which are gravitational, magnetic, or electrostatic. And here I described various examples. A person pulling a bucket using a rope. Now rope is in contact with the bucket, so the bucket is coming off. The force is getting applied through the rope. It's not that a person should always apply, even the body can apply. You are taking a ball, you might be knowing you are taking a ball, and when you hit at some ball. So the ball will move forward and it will hit the ball. So the hand muscular force is giving energy to the ball when you are throwing a ball. Okay? Muscular L will come. Okay? Now let me explain to you gravitational force. You are familiar that you know all fruits from the tree, they fall down because earth is pulling the body downwards. And as such, any two bodies pull each other, but the force is so small that we can't see in that case. But when earth is pulling a body, we can see that the body is moving. If I drop a pen, the pen will fall down because earth is pulling it down. So this force is called force of gravity or gravitational force of earth. So here earth is not touching the fruit. If I drop a pen, earth is not touching the pen. So this is a non-contact force. Now magnetic also you know that if I take a magnet has two poles, north pole and south pole. And if I bring another north pole, another magnet with north pole here. So both north are nearer to one another, they will repel. So this will move here, this will move here. Now here also I am not touched the magnets. There is a small gap between the two. But so this is called repulsion force. So this is also a non-contact force. In the book, what they have done, they have taken one pole for other pole for it to move. They have kept 3 pencils below it, and so that now when it will roll, you can see that pencil by this magnet is rolling over the pencils or some cylindrical object. Is it all right? So this magnetic force are non-contact force. Magnet attracts magnetic material which is kept at a distance. So it is not touching, it is attracting it. Then electrostatic forces are also in similar nature. You might have studied in some chapter that if we take a positive charge body, this body is having positive charge, this body is having negative charge. Then if I bring this opposite charges body one another, they will attract one another, and if I take similar charges, they will repel one another. Or if I take a charged body, you can take a balloon, rub it with cloth or with your hair, it will produce certain charge. And now when you take this balloon near a wall, this will attract the wall, so this will go and get stuck up to the wall. So this is a wall, so a balloon will get stuck up here, will remain here. Because this is magnetic, this is some charge, this is uncharged. So electrostatic force is also a non-contact force. So these 3 are non-contact force, all rest you can say they are contact forces, muscular, friction and so on. ठीक है? So now we'll go. So this completes about forces. Now we'll go to pressure. Now what is pressure? Like suppose you have a nail. You know nail is having very big head and it is pointed at one end. We hammer at this place, then this goes in wood. Suppose this is a wooden piece. If I hammer it here, this nail will go inside this wooden piece. But if I do reverse, if I put this up and this head down and I hammer here, it will not go, though you are applying the same amount of force. Similarly, knife is also very thin at this end. At this end the knife is thin. Here it is quite thick. Here it is thick. Here it is thin. So the thin end we will be using it for cutting our vegetable. Why? What happens? Why this its side should be thin and here why small area or point should be kept on the wood? Because with the same amount of force, the force here is being applied at a very small, contact area is very small. Here also contact area between this knife which is touching the vegetable is very small. So when the quantity is small, so force per unit area becomes large. So this is called pressure. So pressure means normal force per unit area. Normal means perpendicular. We should take the whatever perpendicular force is acting here. This nail is moving here and I am applying a force here. So whatever force this is perpendicular to the surface. So the normal force upon area is called pressure. So for pressure to be more with the same amount of force, area should be less. So area is less in case of nail, knife, then only the pressure becomes more and we are able to do our work. Porter, he keeps some circular, he makes a circular cloth and puts on his head so as to increase the area. Otherwise, your head is like this. So then if I keep the luggage here, only this amount of area is getting touched. But when he keeps it, then this area, full area, he makes in such a manner that the luggage rests on the larger area. So the pressure becomes less and so it is comfortable to him. Is it all right? So this formula you should learn. Pressure is force upon area. Okay, pressure is force upon area. Then that is why those bags, the strap of the bag are quite thick. This is the strap. Your strap is not so thin. If it is so thin, small, then the whatever is the weight of the bag, so that force now here is acting over a large area because this area is touching your shoulders. Here this area, the area is less, pressure would be more, so this will become uncomfortable. Therefore, the straps of the bag are broad. Okay. Now, is this pressure that we are applying is only due to in solids or it is even in liquids and gases? Okay. So, the various activities have been described in the book that shows that pressure exerted by liquid at bottom of container depends upon height of its column. Depends upon height of its column. What we can do? Now you see, I have taken a tube. This is the tube I have taken. So this is a tube I have taken, and here I have attached a balloon. Now, this size of the balloon was when the liquid was up to this place. If I add, as I go on adding more liquid, I will see my balloon is getting expanded. So means as my this height is called height of liquid column. So if my height of liquid column goes on increasing, the pressure here is increasing. Therefore, pressure due to liquid column, though this is not in the syllabus now, but you can learn, is H rho into G. H is height of liquid column. Rho is density of liquid. So instead of water, if you take mercury, then the pressure would be very, very large. because density of mercury is 13.6 or much more than water. And G acceleration due to gravity, that is normally constant. So the pressure increases with depth. Therefore, if this is the swimming pool, so if you are here, the pressure acting on your body is less, but in case you are go to deep here, the pressure acting would be more because this height of the liquid column is more. Is it all right? Then here also we can see, if we use other liquid of less density or more density, we can see that this size of the balloon will change for the same height. Is it all right? So this formula you should learn. Pressure is H rho G. Therefore, in case I take a tube, I am taking this long tube, and here I will show it in this manner. Suppose this is a tube. Now, all along this circular path, you make various holes. Like this is a circular tube, you make a hole here, 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 all along the circumference. And now you have fill up to here. Then you will see that the water that is coming out from all these holes goes up to the same distance. Means all would be in this circle. Same circle. So means pressure due to liquid column at all would be in a same circle. This is my tube, and this is all what is following in this circular. So means the pressure at the same depth here all are at the same depth. Pressure at the same depth are same. Or from formula you can see H rho G. So if H is same, the pressure has to be same. So this experiment can be done in this manner to indicate that pressure due to liquid column is same at the same depth or at the same height of liquid column. Is it all right? So we say liquid exerts pressure on the walls of the container. Liquid exerts equal pressure at the same depth. Okay. So now you see water is exerting pressure. You might have seen that in case a water pipeline has developed some pinhole, the water comes out with a great force. So means water was exerting pressure on the pipe material, and when the material broke, the water is coming out. Is it all right? In the same manner, gases also exert the pressure. For this also you might have seen that in case you take a balloon, the gas is inside. Now you slightly open its mouth. You will see the air is started coming out. Means it was exerting pressure, and now due to pressure the air is coming out. You might have seen a tire puncture. When the tire of cycle or of any automobile develops a puncture, the air comes out with a great pressure. So means the air was exerting pressure on the tire, and as soon as the hole has developed due to pressure, the air has started coming out. So we say liquid and gases exert pressures on the walls of the container. Is it all right? So now we will study the last topic of this chapter, that is called atmospheric pressure. Now as I told you, pressure H rho G. Now similarly, you know that if this is earth, then all up to a very large height we have got air. So we have air here. So this is air. So if I take this small surface of the earth over it up to very large hundreds of kilometers, we have got air. So this air is exerting pressure. By the same formula H rho, the density of the air is very small, but height is quite large. Therefore, air is exerting pressure on the earth, ground surface on the earth. So this is called atmospheric pressure. This is called atmospheric pressure because the pressure is due to atmosphere. Atmosphere means the air envelope around the earth. Okay. Now, you might have seen certain examples. I will give you. Rubber sucker. You know, there is a round rubber thing is there which can be slightly pushed inside or outside. So when I take this rubber sucker, this is a circular rubber thing, and I keep it in, this is having slightly elevation, and when I press it and push it against the wall, then the air between this and the wall will get removed and this will get stuck, and now it will not be easy to remove because there is no air. Theoretically, suppose there is no air between this rubber sucker and this wall. There is no air. So the air pressure is acting only on from the top surface. From the other side, from the wall side, no air is acting. From this side, air is acting. So this is exerting a pressure, because pressure is equal to force upon area, we have learned. So force is pressure into area. So whatever is the area of this circular sucker into the atmospheric pressure, that is the force acting, which is keeping the sucker attached to the ball, fixed to the ball. Is it all right? To show to the public that air pressure is there, there was a scientist, German scientist, Otto von Guericke. He took two hemispheres. Hemisphere means he took a sphere and cut into two parts. And he joined, and he connected it with a tube and took a vacuum pump. So he joined these two and he removed the air. So when this air is removed, now you have got in this manner. He removed the air from here, and these are two hemispheres. So now with ropes, he connected to 8 horses, and 8 horses on this side, 8 horses on this side. They tried to separate the two hemispheres, but they could not do it. Why? Because he has removed the air from inside, so atmospheric pressure is acting only on the outer side. Okay. Now calculations have indicated that on a person's head, this is a person's head, so means you can imagine this is many kilometers height of air is acting on his head. So the pressure due to this atmosphere which is acting on the head is equivalent to around 225 kg weight, as if you have kept a weight of 225 kilo on the head. So you can imagine how large is the atmospheric pressure. But you will say, I don't feel it. If you keep even a 5 kg weight on the head, you will feel it. Now when 225 kg is there, but you are not feeling it. Why? The answer is because air pressure is also acting from inside, because through breathing and through mouth we have got air inside. So air pressure is in our blood. So that is, so pressure inside our body and pressure outside are same. So they balance one another. So we don't feel atmospheric pressure acting on our body. Is it all right? So this completes this chapter. This is quite easy chapter, no numericals, but in higher classes on force and pressure you will have many numericals, and this concept of force and pressure would be used in many places. I hope you have understood the chapter. You can subscribe to the channel if not done so far, and like the channel and press the bell icon so that whenever new video is posted in YouTube, you will come to know. Thank you.